Welcome! Today we're stepping into the virtual chemistry lab. Have you ever wondered how scientists make those pure, crystalline salts? Well, you're in the right place. We're going to break down the exact methods you need to know for your exams, step by step.
So, let's start with the big question, right? How exactly do we make salts in a lab? Now, it might sound complicated, but honestly, it's just like following a recipe. Once you get the hang of the two main methods, you'll see it all makes perfect sense.
Think of this as your guide to mastering two essential recipes. We're going to cover the ingredients, the equipment, and the science behind it all. By the end of this, you'll be able to describe these processes with total confidence.
Okay, let's dive right into our first method, reacting an acid with a metal carbonate. This is a super common and reliable way to make a salt, and it's the one you'll use when your carbonate is an insoluble solid.
Now, this right here, this word equation, is the most important thing to remember for this method. My advice, memorize it. An acid plus a carbonate always produces three things: a salt, water, and carbon dioxide. This is the golden rule. It works every single time.
And check this out. This shows the exact same reaction happening out in nature. That fizzing you see is coral, which is made of calcium carbonate reacting with acid. And those bubbles? That's carbon dioxide gas, the very same gas we'll see in our lab experiment. All right, let's put this theory into practice. We're going to use this reaction to make a specific salt called copper chloride. To do that, our acid will be hydrochloric acid, and our carbonate will be copper carbonate. So let's walk through the steps. First, we measure out our acid. Then, we start adding the solid copper carbonate. You'll see fizzing straight away. That's our carbon dioxide gas being made. We just keep adding more of the powder until the fizzing stops. That's our signal that all the acid has been completely used up. You'll notice how we add the powder until there's a little bit left unreacted at the bottom. This is a really important technique called adding in excess. It's how we guarantee that every last bit of acid has reacted, leaving us with a pure solution of our salts. Okay, reaction's done. Now what? Well, we have a mixture of our salt solution and that leftover solid powder. The goal now is to separate them and then turn that solution into solid salt crystals.
So the next step is filtration. It's a simple but really clever way to separate our mixture. Think of the filter paper like a sieve. It traps the solid, unreacted carbonate, but it allows the pure salt solution to pass right through. And that clear liquid that we collect, that's called the filtrate.
And now for our second recipe. This one is different because both of our reactants are solutions. They're both liquids. It involves a very important reaction called neutralisation, which is perfect for making salts from soluble bases, also known as alkalis. And here's the word equation for neutralization. You can see it's much simpler. Acid plus alkali gives you salt and water. That's it. Notice something's missing? There's no gas produced this time, which is a key difference from our first method. So what exactly is neutralization? Well, it's just the process where an acid and an alkali chemically cancel each other out. When you've added just the right amount of each, the final solution is neutral. It's not acidic and it's not alkaline.
Now, because both of our ingredients are clear liquids, we can't just add one in excess like before. We need to be much more precise. And that's where this special piece of equipment comes in. It's a burette, and it lets us add the acid to the alkali drop by drop, giving us complete control.
So how do we know when we've reached that perfect neutral point? We use a chemical called an indicator. It changes color depending on the pH. In this case, the universal indicator will turn green, and that's our signal to stop adding acid immediately.
Okay, but this leads to a classic exam question. We've made our neutral salt solution, but now it's got a color from the indicator. So how do you get rid of that color to end up with pure white salt crystals?
And here's the clever trick: charcoal powder. The charcoal acts like a sponge, but for color. The molecules of the indicator get trapped in the charcoal, which pulls all the color out of our salt solution. It's pretty neat. So after adding the charcoal, you just filter it out, the same way we filtered the excess carbonate in the first method. After that, the final steps of gently heating the solution and letting it crystallize are exactly the same. All right, we've covered two complete methods for making salts. Let's quickly summarize the key takeaways that you'll absolutely need to remember for your exams. This comparison shows the main differences perfectly. Method 1 is for an insoluble solid. You added an excess, and you get carbon dioxide gas. Method 2 is for two soluble liquids. You have to use an indicator to find the exact neutral point, and no gas is made. This is a perfect summary for your revision notes.
Use this as a checklist to test your understanding. If you can confidently tick off every box on here, then you're in a great position to tackle any exam questions about making salts.
So there you have it, 2 reliable recipes for making salts in a lab. Now the challenge is over to you. What other combinations of acids and bases could you use? What other salts could you create? The possibilities are pretty much endless.